Okay, we know in the database systems, besides the ER model, another important model is called relational model, right? Different from ER model, which has not so concepts as well not so constraints. In the relational model, we only have one concept. It's called relations. Everything in relational model will be represented as relations, which can be further defined as tables in database systems. So in your mind, you may have a question: why we need to learn two different modeling languages? We need to learn the ER model, and why we need to further learn the relational model, and what's the difference between them, why we need to use both of them. To answer this question, we need to know the main advantages of these two different modeling languages. So both of them are used for model the data we have in the real world. And in the ER model, we have many different concepts, right? We know the entities, relationships, and attributes. So the model language is also very simple. We just need to draw some diagrams. We don't need to write down in the code. We just draw some diagrams. It's very easy, right, to draw these kinds of things on a piece of paper based on your discussions. So therefore, because this language is very simple, it is well suited for capturing the application requirements as well as information. When you are doing a brainstorm and a discussion with your teammates, you can draw these diagrams very easily, right? This is an advantage for the ER model, and it also has some shortcomings. This ER model is very hard for the computer to implement for the storage of the data. We cannot store the ER diagram in our computers, right? And we can also not translate everything into ER diagrams into something like graph, right? And to store in our computer. It's very hard. Because of this shortcoming, we need to use another model for storing the data we have based on our discussions. So therefore, we need to use the relational model. Relational model compared with the ER model is also very simple, and it has only one single concept. It's called a relation. We will show the definition of relation in the following pages. Compared with the ER model, it has multiple concepts as shown here. However, in the relational model, we have only one single concept. It's called a relation, right? So everything will be translated into relations. Each relation will be represented as one table. In other words, for each of the relations, we can define a table for storing the data we have. The world will be represented with a connection of tables because we will have multiple relations based on our ER diagram. And we will have a collection of tables. Each one corresponds to one relation. And compared with the ER diagram, these tables is very easy to store in our computers, right? We just allocate a memory space and store the tables in our computers. So it is suitable for efficient manipulation on our computers. It will also provide us with lots of functions and advantages in loading as well as updating and deleting the data we have. We will show the advantage later when we talk about the details about SQL. Because of these reasons, we need to learn both models in this course. We learn the ER model first, so we can know what to model for the applications, and then we learn the relational model, so we can know how to store the data we have into some relations or tables. So they have different advantages and shortcomings. Therefore, we need to learn both of them in our course. So as we learn these kinds of data modeling, you may think the data modeling is very simple. However, the reason we can think it is simple, it is because of the contribution of lots of people in the past generations. Because of efforts of many people, many great computer scientists, so we can model the world and the applications in this way with the ER model first and then with the relational model. And also because of the contribution for many of important and famous computer scientists, some of them also received the Turing Award. We can show them in this page, including the Charles Benjamin, Ed Coder, James Gray, Michael Stonebraker, and definitely we have some more in the future for their contribution to database systems. I'm not sure about you, right? When I learn some new courses, I always wonder why people are working on this kind of topics in the past. And because of them, we have to spend lots of time on this. Especially when I learn history, I get my bachelor degree in China and I also attend high school in China. So China has a very long history. When I was in my high school, I need to memorize so many things about the history. I need to memorize so many people, what did they do in the past at what time, and what's the impact of this kinds of action they do to the history, as well as to our current society. Whenever I learn the history courses, I always wonder why we have so many people and they do so many things. And then we need to learn this kind of things. It takes so much time. Later on, as I learn more about new courses, I feel that this is and because of their contribution, so we can have a society like this nowadays. Otherwise, our world will be very different without them. So we need to appreciate their efforts and contributions. Because of their efforts, so we can have a modern life like this nowadays. Otherwise, the world will be very different. So enjoying learning this new knowledge is important, especially in computer science. So generally, after you choose the computer science as your major, in the future you will never stop learning new things because knowledge will update very fast in computer science. For example, for me, when I started my PhD degree, I do my research mainly on focus on social media, right? At that time, this kinds of problems is a main topic in data mining and even machine learning, and lots of people are working on this. However, after several years, as deep learning is becoming popular, I discovered that my research topics receive much less attention from academia, and lots of people are focused on deep learning instead. Therefore, I also need to learn deep learning, which is very new for me actually at that time. And you see, so the research I'm working on right now is very different from what I did like 2 or 3 years ago. So as you are studying computer science, you have to keep learning new knowledge, no matter in the university or in the near future for you in your career. Right? Like if you join some companies, you always have to learn some new skills about programming language, about new softwares, as well as some new domains. Maybe right now you are working for some companies on cell phones, and in the near future you probably have to work on some like eyeglass or some robots, etc. So new things are popping up, and we have to catch them and also follow the trend in computer science. So keep learning is very important. Okay, so before we talk about the relations, I'd like to provide an example of the relation tables we can draw in this page. In the previous lecture, we have shown some tables already, even though we didn't define what is a table before, right? So here we can formally describe what is a table and how we can draw it. In this page, we show a table. You see the table has several main components. At the very top, we have an entry denoting the name for the table or the relation. So now here the table is for the product. It's about the product relation, right? And inside the table we have rows as well as columns. You see, so for the first row, we have a bunch of entries denoting some attributes. So now for the products, we have the product name, the price of the product, category of the product, as well as the manufacturer of the product. Because the product has a bunch of attributes, we can denote or indicate the attributes of the product as the columns. The first column, the second column, third one, and the last one. Right. So each column denotes a specific attribute of the relation, the product. So in this kind of relation name, together with the attributes, together we define the schema of the relation. It indicates the name as well as attributes of the relation. So for the columns besides the name, we also need to indicate the types of the attributes or the domains of the attributes. And for the name, it is a string. For the price, it is a float number. Category is a string. Manufacturer is another string, right? We'll indicate these types later. And at the bottom of the table, we have 4 rows, right? So for the bottom table, we can read the table in each row instead. So this is the first row. This row denotes one product. For example, the first row denotes a gizmo. The name is the product of the product. The price is 19.99. It's gadgets. The manufacturer is Gizmo Works, right? So this is the one product. This entries denotes the attributes of this product, the name, the price, the category, and the manufacturer. And second row will be another product. So it denotes the power gets more instead, and it has a different price, the same category as the first one, as well from the same manufacturer. And the third row denotes the third product. It is single touch from the Canon, and it has a price as the category and the manufacturer. And the last one will be another product for the multi-touch and Accenture. So when we read a table, if we are checking the schema for a table, we can check the top first. We can see the name of the relation as well as attributes of the relation in these columns. As later on, if we want to read the data we have inside the table, we can read it row by row instead. This is the first product, this is the second one, this is the third one, and this is the last one. And for the values we have, they have some domains depending on the attributes we have. So for the entries, we store the data for each of the data tuples. And depending on the attributes, they will have different kinds of types of the data. This is a string, this is a float number, this is string, this is another string, right? So this is an example of a relation table we can draw in our database systems. And follow up, we will show the definition on how to represent a relation formally. So in this course, generally we don't differentiate the relation from the tables. So generally, given a relation, we can draw a specific table for it. And given a table, we can also define a relation based on table schemas.